Hi everyone, welcome to the new episode of the podcast series When Machine Learning Meets Data Privacy. I'm your host, Fabiana, and today it's all about encrypted machine learning. We are already familiar with encryption, and we tend to think about data encryption as just a black box. So one side enters the encrypted data and a secret key, and on the other hand, we just get gibberish, or as we call it, ciphertext. But what about encrypted machine learning? Does that mean that these models just get more black box than they already are? What's new about it? And what are its benefits? To explain all these questions, I have invited Théo Ryffel, one of the founder members of the Open Mind community and a reference name in what concerns privacy enhancing technologies, such as federated learning, differential privacy, and homomorphic encryption. Hi, Theo. It's a pleasure to have you here speaking for the MLOps community about one of the hottest topics of the moment privacy for machine learning. I guess there's no one better to introduce you than yourself, so please tell us a bit more about you and what you have been doing.
Hi everyone. I'm very pleased to be here today. I'll present myself a bit. I'm part of the OpenMind community. I'm the cryptography team lead, so trying to coordinate all the initiatives around cryptography at OpenMind. Second, I'm a co-founder of a company, healthcare company based in Paris, which is named Arkhn. Third, I'm a PhD student at ENS in IRIA in Paris, working on cryptography, of course, and also machine learning.
Out of curiosity, how have you started in this path of first machine learning and then specializing yourself in the world of cryptography?
Yeah, so actually, I've started my studies in AI in Paris and then in London at Imperial College. So I was like mainly work on AI solution, big data, stuff like this. For the final year research project, I selected a project with a lot of buzzwords. It was named Federated Machine Learning on Medical Data using the blockchain technology. So, like you have everything together. When my supervisor introduced me to OpenMind, so I discovered like this emerging community. It was like 2 years ago. So this had me to read some paper around like cryptography, and then I thought, okay, that's like a very cool application of AI to combine like AI with privacy enhancing features, and that's where I started to combine both. And I really enjoyed it.
To be honest, our community is very tech savvy, so your audience know a lot around machine learning. But I think it could be interesting to get from your side what is about and what is the novelty of having encrypted machine learning.
So I guess you all know about like cryptography, trying to encrypt some secrets to share them to other people. Before I start about like on encrypted machine learning, I would like to speak about encrypted computation. So encrypted computation is really about like not only you have a secret that you encrypt, but you can also operate on it to do like some operation and to transform it into something different. So maybe you could like something very simple is maybe like we are all together and we want to compute the average of our salary, but we don't want to disclose our salary. So one example of encrypted computation would be we all take our salaries, we encrypt them so that we cannot like read them anymore. And then in a special encrypted space, we compute the mean of all the salaries. And only this result then we decrypt it together and we get the mean, but the average was nothing else. So that's like one example. Actually, that's like a very simple example, but then you can do a lot of computation when you can like combine many of them and you can do like a complete, like for example, a complete like a model evaluation or even like a neural network training. And that's where you shift from encrypted computation to encrypted machine learning. To do this, like you have a lot of techniques that have like been developed over like the 10 last years. You may know some names like homomorphic encryption or secure multi-party computation, which I can explain very briefly. So encrypted computation So as I said, like you compute over own encrypted data and you do like no leakage, which is like the main interest. So how does it work? And I would explain in particular secure multi-party computation. So the basic idea is very simple. Is the idea is to share ownership of a number. So that this, let's say this is a number, and I will build two shares out of it. So okay, I have this number, like it's a 7, it's a dummy number. I build two shares, but these shares are truly random. Like there are some people randomly. And what I can do is I can give one share to Alice and the other one to Bob. And this way, like Alice has a share of my secret number, but has no idea and no way to finding what my secret number is. And same for Bob. So this way, neither Alice or Bob can reconstruct the secret. And what is really cool is that if they want to reconstruct the secret, they have to all to agree together. So that's what we call shared governance, and it's a very cool feature about secure multi-party computation. Then you can do some operation on these shares. Like maybe if Alice and Bob compute locally like the double of the shares, if then they reconstruct the result, they will reconstruct the result which is the double of the secret value. That's a very simple operation. Actually, you can also do like something like the addition. Maybe, let's say I had actually two secret values, like 7 and 3, at a secret shared. Alice and Bob can locally add the shares and then reconstruct the sum without having any ideas of that my two initial values were 7 and 3. And then you can do like more complex stuff like multiplication, which is a bit more subtle. And with this in mind, like if you can do addition, multiplication, even like you can also do a private comparison, then you have all the building blocks to do a complete neural network evaluation. And so in that case, that's exactly how you shift like from simple operation to machine learning private evaluation. Because like if you look at models are just like a collection of parameters that you can sequester exactly the same way than I've shown with this like quite simple numbers. So that's the ideas about secure multi-party computation. So as you see, it's very, very simple. It doesn't require like heavy cryptography. So that's one of the cool feature of these techniques. But as I said, there are like many others, but I just wanted to display one.
In the end, what happens is instead of you having public kind of weights of the model, you have them encrypted, and the results can only be decrypted by, I don't know, the owner of the data, is something like that.
Exactly. So the people like for secure multi-party computation, it's like it's all the shareholders should agree to reconstruct the data. In other type of encryption, you will have like a secret key which has to be used to reconstruct the data. It depends like of the protocol, and you can encrypt either the data, either the model, or both. So it really depends on the use case.
I'm curious to understand, like, for example, you also mentioned the homomorphic encryption and also the possibility of encrypting data versus encrypting the model. Can you give an example where one is better or more suitable than the others?
It depends on exactly the use case. So we'll consider several use cases. Maybe you have a situation where the data is sensitive and the model as well, like but the model is owned by a service, a platform, or something like this to do a prediction. In that case, what you can do is encrypt the data, send it to the platform, and then they won't have to, because they already have the hold the model, they don't have to encrypt it. So they will just like combine the plain text model with the encrypted data, which should be faster than having both encrypted. That's an example because this way, like the model won't leak and the data won't leak, so that's sufficient. For a situation where we use secure multi-party computation, in that case, because we will all together we will hold shares of the data If I used a plain text model, we will you would have to share me also a plain text version of this model, which is like not very suitable. So in that case, what you will do, you will also like secret share the model. So it really depends on how sensitive the model is versus the data.
And based on this and all this, use cases, and usually there's a lot of questions about this. And I feel like although there are new methods, there is still a lot of doubts in the market about the new privacy enhancing technologies that are emerging. And we know that a lot of new methods in the area of cryptography are also appearing. What is your opinion on this, on the maturity, and how you think we are ready for the enterprise world, let's say?
Actually, I would say it really depends on the privacy enhancing technique that you use. Encrypted machine learning is one. Maybe you're also familiar with like federated learning, which is also a nice way of having privacy because the data won't be disclosed. But in that case, you make the assumption that the model is public, which is also okay in some cases. And you have like also other techniques like differential privacy also, which gives other guarantees as well. The level of maturity and adoption is really different between all of this. Like for federated learning, for example, it's already deployed on many smartphones, like on Google smartphones. They have this use case where they try to predict the next word and that you might type on your text message. And so they use like they train the model on all the different mobile phones. For encrypted machine learning, it's less advanced. I would say like many people like understand that it would be really cool to have it, but they're not really aware of how mature the solution is, how to use it. I think there is a big issue about awareness. That's like something that is still missing, and it's important to explain that this solution exists. It's not completely practical for the moment, but it exists. There are like great progress being made over the last years. That is the most important thing for adoption. Obviously, the other thing is so once you have a technique which has been like developed in the research area, then you have to build tools and projects that help to use them for people who are not like maybe senior cryptographers but would like to protect the data.
Based on that, I know that you have experience in the market and also with the open mind community. You probably have uh, been having interactions with different companies. In your perspective,
Mhm.
do you feel
Mhm.
like it is easier for tech-based companies understand, for example, the importance of maybe using things like encrypted machine learning versus a company which their core business is not exactly tech, let's say?
Not exactly. I would say like the thing that makes a difference is that many companies or fields are blocked by privacy, data privacy issues because they're just not allowed to do some stuff. You know, like they're not allowed or not willing because like if you take like banks, they're not willing to share some records that maybe they could share, and also like private data that just can't share because it's like private information about the client. So in that case, this like companies are not really like tech companies, but they have a problem. Is that they cannot cooperate to maybe like to fight financial crime. They would have a great advantage of having such tools. So in that case, what needs to be done is to speak to that people understand where they're blocked. Same for healthcare. It's exactly the same. Like the company I've co-founded, we have this issue, and where we need to share data because we want to have like stronger models, but you have to do this in something a way which is privacy preserving, obviously. What you need to do then is maybe so for banks, to go to hospitals, and to explain, okay, here you are blocked. If you had this technology, which you have to assume that it is secure because like you're not an expert, and I claim I'm an expert, but then it's another topic. Then you have to convince them that it's a good solution. This thing, a bit magic, will help them just to solve their problem. So I think yeah, people with data, private data, are like the one of the more able to start adopting this
Although it seems a bit off as they have a lot of private data, as you mentioned, and it's quite interesting about your own company. I was curious if, of course, if you can share. I think it would be very interesting to understand whether, for example, healthcare is and how you are helping healthcare leveraging, for example, encrypted ML. And if you could share like a use case or something, that would be awesome.
For healthcare, I would say again, like you have several privacy enhancing techniques. Like I think hospitals are more ready to use further learning. That's like something which is really natural because hospitals like used to cooperate together. So you know, like you have like maybe 10 hospitals who say, okay, we have this super cool research project. We need to train that model on a lot of data. Let's put all the data together. And then, if you just, actually, you can just keep your data on your hospital and don't share it with the other one while training the model with the same accuracy. Um, then it's something that they understand a lot because there's a big issue about sovereignty of the data. Even if the hospital trusts each other, which is often the case, it's important to have the control of the data. So for further learning, they are really interested. We have spoken with hospitals which are like, they say, okay, that's a cool thing, and we would like to try it. For encrypted computation, you need also to have the model which should be as a private. That's not always the case. Like it's in the situation that we have, as I said, like hospitals could share data, but because they trust each other, but they want to go one step beyond and try something which is like more private. But obviously, the model is really not an issue. If the model was an issue, which could be the case if there's like one pharma company which has trained this model using billions of like millions of dollars and say, okay, you can use my thing as a service, but the hospital say, okay, I don't really trust you. I won't send you my data like this, and these two parties don't really trust each other. They want to use maybe like the model as a service, and so in that case, they're a bit blocked, and that's the situation where encrypted ML could really be developed. We don't have like for the moment some concrete use cases, but that's like where I envision that it could happen.
No, that's a very interesting application indeed. And to be honest, I was not even aware that that kind of situation was able to unlock, for example, with encrypted machine learning, which is very positive. But I do have another question, and I think that that one I feel it might be a recurrent one when talking about encryption. Is there is a trade-off, or it's not a trade-off, but what is the complexity of implementing such kind of solutions
Mm.
versus, well, the benefit it brings you? Plus I'm thinking, okay, encryption or cryptography, it's usually like a monster for the majority of the people. So I imagine that in terms of skill set, it also requires something extra.
So first, I will respond by talking a bit about OpenMind. At OpenMind, what we're trying to do is we're trying to help people which are familiar with tools like PyTorch, TensorFlow, to use privacy enhancing techniques in a very easy way. Like it's really like you take a tensor and you call dot encrypt on top of it, and then you can do encrypted operation. That's it. That's so. In terms of using this, we're trying to do this in a very simple way. But of course, you still need to know what you're doing. Depending on the encryption protocol that you use, you don't have the same security guarantees. Like a very simple example, you have like two big families of crypto protocols. The one are secure against honest but curious adversaries. What does it mean? It means that you suppose that you're interacting with adversaries, but which like they will try to infer everything that they can. Like if they see data, they will keep it and maybe like do something bad with this, but they will not. They will still follow the protocol. They won't try to do like some special stuff to trick you. That's the first family, which is obviously like the best scenario and where we have the most efficient protocols. And the second one is protocols which are secure against malicious adversaries. In that case, you assume that the adversary is trying to do like all that it can to try to disclose some data. It will like do stuff which was not intended in the protocol, try to like to cheat and to do like all the bad things. There are also some protocols for that kinds of adversaries, but they are much slower. So in terms of runtime, like okay, if I want to have this machine learning workflow, I want to do it now in an encrypted mode. So it used to be very, very, very slow. Like I would have said, like 100 or 1,000 times slower. But over the years, it has like this like gap has reduced a lot. And there is a paper like from this like spring which says maybe I can quote it because I have it here. They say our findings indicate that private deep learning over CPU is a factor of 6 times the clear text execution. So we have only a factor of 6. That's really cool. And like over GPUs, of course, it's higher because crypto protocols are not optimized for GPU for the moment. So it has reduced a lot. is still more. It will always be more. Like you cannot have everything, but it has like reduced a lot, and you can start to have practical scenarios. Like if you're familiar with AI, like a few years ago, there was this thing when people said, okay, we can do an encrypted convolutional network. And now, like this year, there are some application of encrypted ResNet 18, which is like, it's much bigger. So we're doing progress, and now for more and more application fields, we can have some encrypted settings which are convenient enough. So yeah, just like this was a long answer, but what I would say is the syntax can be very easy, but you need to make sure that you're not using security guarantee, which is not precise enough for your use case, which is not good enough. In which case, you will have problems, definitely.
Yeah, makes sense. So, above all, and although simple in terms of code, let's say, it's not as simple as just a line of code. You always have to know what you are doing. So, that's a great input about this. Based on that, and now that you've mentioned that cryptography and especially the one related with machine learning and models have been evolving through time, do you feel like encrypted machine learning is yet in its baby steps? And how do you feel about the evolution and direction of this kind of technology?
It's a very, very recent technique, and the research is still very, very active around this. Many progress are being made like every year. I'm very optimistic about encrypted machine learning because when I like as I told you like the 6 time overhead is really not a lot. I have the impression that so research is discovering really efficient protocols. Communities or companies like OpenMind, like Facebook and other, are building libraries to make this tool practical for ML and data scientists. Everything is going in the good direction. So on that side of thing, I'm very optimistic. What I really I hope, is to see like more production ready examples of people who are like using it, providing us some feedback, and this will also like be possible like for healthcare. For the moment, like at least in France where I'm located, it's very complicated to share some data, even if you say it's encrypted, because it's medical data and there is a strong regulation around this. So you have to really actually there doesn't exist a proper regulation around this, which encourages people to use these techniques. And I think regulation has also a role to play here to when it's possible to force people to use such techniques. And so yeah, that will also like these techniques to be more used in practice.
It seems like just in everything, we need first the regulation to make it mandatory before someone starts implementing, especially around privacy. That's the usual behavior. Okay.
Yeah, yeah.
It's true. You already have mentioned the open mind community, and we have talked about it. And I feel like, especially in the realm of privacy, open mind has definitely played a major role. I had the idea that you were already in open mind since more or less the early days of the community. But essentially,
Mhm.
could you share with us? You have already mentioned it, but could you share the view and the objective of this community overall?
Of history, so OpenAI was founded by Andrew Trask in 2017. So it's now like 3 years old. So there was like from the beginning a very 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 big people were really enthusiastic about it. There's been a lot of reflection and OpenMind has changed a lot. There was a day where it was involved with blockchain. It's not the case anymore. So it's like moving a lot. End of 2018, we had our first white paper and the first encrypted demo, and the year after we started collaborating with many companies, and so like that's like has been like a long journey. But so the motto of mine is answer question on data you cannot see. So like that's the main idea, and what does it mean? We need to build the tools for people to do this, to be able to collaborate with other people, to help them on data even if you don't have a direct access to this data. And this objective is pursued now by like The community is over 8,000 people, so that's really really huge. I think there are like maybe 30 teams working on different projects, like on the so there's a PySift and PyGrid libraries, which are like the more famous, but there are many others to port the privacy enhancing technologies, like on mobiles, on iPhones, on Android, on the browser, like a lot of initiative around there. Oh, there was a course last year, a Udacity course. So I think the goal of Open Mind is really to educate people, to connect with companies, to understand what they are looking for, and to build like tools that are open to anyone. Everything is obviously free, even like the course on Udacity. In September there was like a free conference called Arkhn, which also gathers like a lot of researchers from privacy enhancing techniques and students and companies together. So it's really like privacy should be open to anyone. It shouldn't be a business. And I think that's the vision that Andrew Trask is leading, is to say, okay, let's build the tools and let's share them with the next number.
I have to say that's a very bold vision and very interesting, especially on the sense that, okay, as data scientists, we are so used to see the data and to dig into the data that the concept of being able to produce machine learning without having the possibility to see, I feel like it would unlock a lot of new innovation in areas that usually are, well, more restricted in terms of access to data. And based on what you mentioned, and yeah, I understand these two, PySift and PyGrid, are definitely the most known. Can you just give us a preview, just to give a taste of what is the, or are they, so our audience can go and play around and start getting into what are these libraries?
Just like a very short concept is about providing wrappers around like a major deep learning frameworks to be able to send tensors over to these workers, to encrypt data, to use several techniques, including so like differential privacy and stuff like this. And PyGrid is a library providing the network. So a complete network around real workers located on several machines to be able like to communicate with them and really like send data and like the infrastructure. You can do like very very different stuff with these libraries. Like maybe most simplistic example is like two people, like maybe like a scientist and someone which has data, maybe in a hospital, which are like connected on their notebook, are connected together, and they are doing like data exploration, so and analysis. So that situation, what you can do is you can directly, like maybe if I'm the data scientist, I connect to the remote data, and I can also remotely I can do some operations, some small analysis, and maybe I can have some aggregated output back, but not the full data. I can be held by the other person on the other side, maybe on the hospitals, and these two persons can really like just go on a phone, use a discussion on the phone, and in the meantime interact with the same data together. So it's like almost like a Google Doc, but for like sensitive data, and where you cannot just link the data. So it's very that's a very simple but I think useful example. You can also do like classic pattern learning, where you really like set up a task where you connect to several nodes which have some data. You set up a training task. You say, okay, for 10 epochs, please train this model. Try to synchronize every epoch or stuff like this. So that's like more classic pattern learning. And then you can also do stuff around encryption. So that's the part where I'm like the most involved. So you take your network and some data, you encrypt it, and then you do like either you do simple evaluation, like typically a ResNet 18 that you can evaluate, or you can take a neural network and do some training over some data which is encrypted. So all of this is stuff that are currently in PySift. Um, we're working on differential privacy, so there are already some stuff in OpenMind different privacy, and we're trying to connect this with machine learning to do deep learning with differential privacy. But yeah, maybe just to complete on this, like there are like lots of tutorials on PySift and PyGrid, so definitely that's a good way to see everything. Like I've just explained with my hands, but you can code is very easy to read because it's very like PyTorch or so that's very.
I will leave linked all the tutorials and quick links to access all these platforms and solutions, so our audience can start trying. We are reaching the end, but before, we always have like a section of our podcast where we like to give the microphone to our guests. So usually we enjoy to hear out some stories or experiences that you feel like is very useful to share with us. So I give the microphone to you.
Over the last 2 years, we are like the community has grown a lot, and our like main question was to see how we can have new people joining the community, getting involved, and start contributing to the code or using the code for the project or stuff like this. And I think like it's actually very challenging because like the code is evolving very quickly. It's like sometimes it's a bit complicated to read, and it's can be hard to get on board on this. So yeah, I think we've been doing a lot of efforts there, and we've learned a bit about like who can join and what are like the good things to know when you join the community. Maybe like first, if you're a student, so we have, as I told, we have tried to build some tutorials to help people like using the tools, but it's always a bit challenging. And what I would recommend if you want to join a community like OpenMind, you don't have to be like a crypto expert or anything of this. Really not. But a good thing to have is to have a personal project. Like maybe you're a student, you have like a research project or a code project, and that's a good opportunity to you, because like you need time to dive into the code and to meet the different teams, and having a personal project is really a good occasion to get involved, and what is like many people will join for a project is like after the project was over, people stayed because like they had discovered like many people, and actually they just like were enjoying their work at OpenMind. So really, I know it's complicated. Like I spent my first month when I discovered OpenMind. It was really complicated to try just to run the demos. The demos were not working at the time, and the code was changing every week. But at the end, it's really worth it, and you meet a lot of amazing people. That's like the student's perspective. And from a company's perspective also, because obviously, as I was working at Arkhn as well, and we're trying to see like, how we can work together. I think it's a great opportunity for companies to use these open source blogs, which are like well maintained. You have like a strong community behind, and it's also a way not and the best thing is not only to use it but to cooperate with them, because like obviously if you're building use cases, it's very helpful for contributors and for opponent to better understand, okay, people are actually trying to do this. We write the library in a way which is more convenient for all these companies which are like which will put this code into production. It's an opportunity like for nice collaboration to meet like researchers, great scientists, and so definitely like I would recommend go for open source communities like OpenMind, and you won't regret it, and you will meet people that you will maybe hire later, and yeah, it's really like a nice way to collaborate, to try stuff, and especially like what I know for OpenMind, the community is really active. We have a Slack which is like definitely maybe too active for me, but are very active. You can ask questions. You always get help, and cannot like just yeah. If you don't know, you just try it, and you will. I bet you will enjoy it.
That's awesome, and that was an awesome share moment, because usually we are not aware of how open source code projects do evolve. So from zero to something that can be used by major companies. So that was an awesome experience. And by the way, another question that I have: you mentioned that you usually in September you host or you help PyCon. Is there any other like events that you also held. I think you have a session where people can present their projects. Is that correct?
Yeah, we have AMAs featuring some contributors from Open Mind, where anyone can ask a question live. We have also some events where we present, like every time we have a release, a big release of the library, we do a public event around this to speak about like the new features and how to use the library in this new version or stuff like this. And last also we have meetups, an incredible number of meetups all over the world, in Paris, of course, but also like in many major cities. That's a good way to also meet with the community of people which are like close to you and try to start local initiatives. So yeah, I think like the Twitter of Open Mind is share a lot of about these events. So it's definitely like to follow if you wanna to learn more about what's happening at Open Mind. Yeah, a lot of events going on the daily basis.
Okay, Theo, it was a pleasure to meet you and to have you here as a guest, sharing your experiences not only on encrypted machine learning, but also on the open mind community. And yeah, that's it. It was awesome. Thank you.
Thank you a lot, Fabiana.